So our next speaker is a ML and big data researcher. He works at Symantec as a software developer engineer. He has also been awarded as the most influential young data scientist of the year 2019. So I would like to welcome Akshay. I hope he is already here. So the stage is all yours, Akshay.
Hey everyone, I hope you guys can hear me. Abhishek, if you can add my screen to the stream as well, that will be helpful. Yeah, okay, makes sense. I'll quickly start sharing it. Sorry, presenting it. Yeah, all right. So, before we start, just want to give you a brief about the session as well as about myself. So this session is going to be about inferring human features using deep networks. So this is a combination of both image processing, computer vision, as well as some in concepts of machine learning. At the same time, we'll also look at some of the shortcuts to use when you're working with machine learning, and this can work for your specific use case. So feel free to, if you have any questions, feel free to, drop in the live comments and I can pick them up one by one, either after the session or during the session as well. So without further ado, I'll just start. Okay. So, and you can find me on akshabahadur.com. I'm also on Twitter, Akshabahadur3. So if you have any questions, you can feel free to message me or tag me in any of the posts, and I'd be more than happy to answer your queries. A big thanks to the GDG Chennai team because organizing this event at this time of at the same at this time, as well as making sure that everybody's engaged, is definitely tough. So a big thanks to them, especially Abhishek and Jui, for taking care of all the logistics during this time. And I hope everybody who is listening to who's part of this conference has fun and also at the same time gets to learn something new, and of course is safe and at home as well. So a bit about myself. My name is Akshay Bahadur. I'm an Intel software innovator. I'm also a Google developer expert in machine learning. Apart from that, I work at different companies. I have been part of a company called Symantec, which is in cybersecurity, where I worked in big data and analytics. So it's pretty interesting. Uh, so before we start, an important link that I have is this one. So if you want to have a look at the repository that I'll be using, go to bit.ly slash DevSangamam hyphen 20. So if you click on the link, you will be directly transported to my GitHub repository, which contains all the details of the slides, the codes, as well as other important links that you would want to follow up. So, after the session or maybe even during the session, you can definitely have a look at this link. So it's bit.ly slash devsangmam hyphen 20. All right. So let's start with some basic understanding. And by basic understanding, I mean that there are some concepts that we learned back in our college or back in our school, which is very important. And we don't really understand the importance of it until we use it in a machine learning problem or until we use it in any problem going forward. So we'll start with a very basic question or a very basic, very basic data set. So the data set is called as MNIST. Everybody must have heard of it who is working in machine learning or just started with machine learning. It's basically digit recognition. So what I'm trying to do here is, before we go any further, so this presentation will contain some videos of the demonstrations. It will contain some code snippets. So it will not contain the entire code snippet. For the entire code snippet, you have to follow the link that I just mentioned. You'll find the Collab notebook in that link, and you can then have a look at the entire Collab link, which will contain a lot of details. So just for the sake of this presentation, I've kept it short. So this function, what it does, that it shows the data. So we'll have a look at the data. So this is how our data looks like. So we'll have the image of the digit 3, and it has a label which is of digit 3. Okay. So So I try to do something. I'll try to see the shape of my image. So it's a 28 by 28 sized image, which means that it has 28 pixels in height and 28 pixels in width, and it is only black and white. So you don't have a color channel in between. And if I try to print the the numbers or print the pixels, you will find that these pixels they range from 0 to 255, and this is because the pixel intensity varies from 0 to 255, and that's what you see when you actually print out the pixels of each image. Now, what we see in this image is that our data is scattered or the data is skewed. That is, in most of the cases, you see that the image has only the digit 0, which means that it does not have any color or does not have any intensity, and you also see intensity of 255. But this is a very highly skewed data set, and this is not very problematic. But at the same time, this makes our model to learn very slowly. Okay, so now what comes into picture is a very simple technique called as normalization. And normalization is something that we guys have studied back in our schools when we started out with statistics. So what is normalization? Normalization is basically you make sure that the spread of the data is within a certain range. Okay. So what I do is that I divide the entire data set by 255. Okay. Which means that I have divided the entire data set by the maximum intensity. And when I print out the result, I get my data set which lies between 0 to plus 1. Okay, so earlier we had data sets ranging from 0 to 255. Now it is ranging from 0 to 1. Okay, and this is pretty interesting because this concept came from statistics and it actually helps us a lot when we're training models. So let's look at that. So I do some analysis, that is how many numbers of examples are there, and then of course how many are my training set and how many are my test set, and then I've defined a simple model. It is a simple fully connected layer without any CNN network in between. Now this is just some basic a cluster I mean this is some model outline that we are looking at. And now, if you look at it, if I train the normal data set or the unnormalized data set that I had, the value ranged from 0 to 255, I see that the loss is 0.26 and the accuracy is the loss is 11 and the accuracy is 26%. And this is after 2 iterations. And if I do the same thing with normalized data set, what I find is that the accuracy has increased to 93% and my loss has actually gone down to 2.24. So with a simple technique that we studied in mathematics or that we studied in statistics, we have actually increased our accuracy by 4 times. And this is something which does not really concern us at this point. But all I'm trying to say is that all the concepts that we have studied in the past, whether it's mathematics or whether it is electronics, each of them plays a very important role when we are working with such a diverse field like machine learning, which has a lot of integrations with each technology. So with a simple technique in mathematics that we studied back in class 10th or 12th maybe, we have actually increased our accuracy by 4 times. Now we'll come to the main topic that we wanted to discuss. Is we will be using computer vision or OpenCV. Before that, this is just a simple outline of the accuracy and the loss, which you can see, and you can find out that the accuracy on the normalized data set is very high. So before we start, this is now we are now coming to a main concept or main aspect of our presentations, is that you want to feed the content through webcam. So I will display a couple of different techniques of how exactly can you do that. So now feeding content means that I will show something to the webcam. I hope that my webcam is able to recognize it, and it has different a lot of complications, but I will try to abstract that. I will only tell you the important aspects, and then of course you're free to explore it as much as you want. And we have something called as OpenCV. It's a Python library that helps us do some calculations using on image processing. Okay. All right. So we have something called as cap.read, which means that I just want to read from my webcam. Okay. And then I've written a function called as get image contour threshold. We'll discuss this in detail, but let's just imagine that it gives us some contours, and contours are our area of interest. Okay, so let's say if I've showed an image of myself, maybe my face is a contour because that's an area of interest to me. And what I do is that if I find a contour, that is the length of the contours are greater than 0, and the area of the contour is greater than some threshold value, or maybe it is a maximum of all the contours, then I do something. Basically, I get the image, I resize it, and at the end, I do a prediction on the image. Okay, so this is the basic concept, or this is a basic ideology that we follow. At least in this session, is that we will get some contours. We will get the maximum contour. Basically, we want to make sure that because we can have some we can have some background noise. So we will eliminate that. We'll only be looking at the contours which are the highest value. Okay, and then after getting that, we will just call a predict method on that image that you have seen. Okay, so basically the prerequisite for this is that you should have a trained model. Okay, so we'll not discuss about that, but let's just assume that we have a trained model. The only thing is that you want to integrate it with computer vision or OpenCV so that we can do analysis through webcam at runtime. Now, the get image contour threshold, this function, what it does is that first it converts the image to a grayscale image because working with color images is slightly complicated at this point because we haven't discussed a lot of things. So we will just convert it to grayscale. That is, it has only one channel now, black and white. And then I'm blurring it. Blurring basically means that I'm reducing the edges from the from the image. Then the important function is this one. Okay, so because of OpenCV, it comes with a lot of out of the box functionalities. So we don't have to worry about the details of it at this point. We can just understand that what it does is that it finds areas of interest depending on certain threshold values that we have set in the past, and it gives us some contours, and we are returning these contours or these areas of interest to our main function, and then we are performing some calculations on that. Okay, so this is the basic outline that we have. And using this functionality, I have developed an application which is called as digit recognizer. So if you look at this video, all I'm trying to do is that I'm showing it the image of a digit. Okay, and my OpenCV application gets the contours from the image and then trying to make predictions on that. So right now you can see that it gets the image of the digit 7, and it makes the prediction 7, and all of this happens in runtime. Okay, so this is the basic concept of one of the most simplest applications that you could develop using machine learning and computer vision, showing something to the camera and making sure that your model predicts that particular image. Now the next thing that I wanted to discuss is writing through webcam. So right now we were showing something, we are showing an image. Now if I want to draw something using my fingers or using my fingers as an input modality, how can I do that? So once again, we will go to something very basic. Okay. So once again, cap.read means that we are reading our image. Okay. Then we have a very important function which is called as in range function. Okay, so what it does is that my image, uh, in the image I have a region of interest. Region of interest basically means that region is important to me and I would want to only analyze that region. Okay, and in range what it does is that it gets me the range of the colors that I'm interested in. Okay, so within a region of interest, let's say if I have a green color, so this lower green and the upper green are the boundaries of the color green in BGR format. So every color is made up of BGR, that is blue, green, and red. They have certain pixel values, and that amounts to the color green for the computers. So what I've done is that given a region of interest, I want to make sure that I get only the color green. And once I get that, I simply do a bitwise AND. Okay, so bitwise AND is a concept that we have studied in mathematics or maybe in electronics as well. So you'll do a simple AND operation. So if I do an AND of an image and a part of the image that contains only green color, so after the AND function, I will get only the green color from the entire image or from the entire region of interest. Okay, and this is a very simple concept which I have explored or exploited, as I can say. And once that happens, I again call the find contours function, which basically gives me the contours with respect to a color that I'm looking for. And then um, using this contours, I'm trying to do something. And this is slightly complicated, I'll say, but you don't need to worry about it. It's fairly straightforward. So if I find a contour, if length of the contour is greater than 1 or equal to 1, which means that I have found a contour, okay, what I try to do is that I add this add this point, or because everything will be a point, if you're getting a contour, it will have a central point. Okay, so I'll get the central point and I will store it in a queue. Okay, so let's say if I try to draw something, if I try to draw something with my hand, it's going to get my hand and it's going to try to trace out the path of my hand, and it's going to use that what can you say, coordinate, and store it in a queue. Okay, and once it is stored, what I do is that once I remove remove my hand from the image, that means that I have drawn my image, or I have drawn whatever I wanted to draw. And once that happens, I simply call a find contours function, and I send it for predictions. Okay, so it's slightly more complicated at this point, but the whole idea is to trace out the path of the object that I want to, that I'm interested in. And then once I have drawn something, just keep on adding the points or the central points, tracing out the path to queue. And once I remove my hand, or once I remove my object, it's going to send it to predictions. Okay, and this is a simple example of that. So this is called as DG encoder. So right now you can see that I have a small blue color object in my hand, and I'm tracing out the path of that blue colored object. And that essentially I'm drawing a digit, and then I am asking my model. So I have three models. I'm asking my model to draw the same digits from their own memory. Okay, so I've created a model, an encoder function, which basically encodes all the digits to a lower modality. And then once I draw the image, they try to predict, or they try to draw that same image, or draw that same digit from their own memory. Okay, and this can be easily done if I have this functionality that I just showed you. So now we have seen something for drawing. Now we will discuss about hand gestures. Okay, so let's say if I want to get the hand gestures from the image. So let's say right now if I have something like this, so I want to just see my data. Okay, so this is me pointing my finger upwards, and then you can also have a victory sign, at the hand gestures. But now what you see is that this is a black and white image. So naturally it means that we have some filters in place which gets the entire image. It gets the hands from the entire image, and at the same time it filters out the black and white aspect. So only you will get only a black and white image of your gestures. And this performs well because you are not worried about the black and white, or maybe you're not worried about the color aspects of the image. At the same time, it's very fast, so you can do your predictions or calculations at runtime without worrying about the resources. So this is a model that we'll be using for this. So this is a simple CNN model. Okay, we'll not worry about the model at this point. And this is how it looks like. So I have trained the model, I had the gestures in place, and you can see that it is almost 99% accurate, which does not make sense, but for the sake of argument, we'll say that it's a good model. Now comes the interesting part. Okay. So now we have seen the power of in-range functions in CV2, which means that I specifically get a specific color from the entire image. And similarly, I try to do something of similar sorts in this as well. So the two values that you see, 250, 60, and 25, 150, 255, are actually colors or boundaries of the skin color. Okay, so these are static in nature right now. So mostly everybody will have the skin color bit ranging from this lower value to the upper value. Okay, so when this happens, again, similar concept, a bitwise hand, which means that I will only get my hand skin color, not just hand gestures, skin color from the entire image. Now the important aspect is I have to extract only my hand gestures. Okay, so for that, we have certain other filters in between, which are slightly more complicated. We will not discuss that at this point, but you can understand that these are some filters which I have added so that I can extract my hand gestures. And then at the end, I'm doing a simple find contours, which we have been doing for the last 3 examples, and it's pretty effective. Okay. So once we have the contours, we get the maximum contour. Um, and then at the same time, we just do a predict model or KRAS, which is a function which basically predicts, given my image that I've just extracted from my contours, and making predictions. So we'll see. So this is an emojinator project that I did. It's pretty interesting. So right now, what you see is one of the work that I did a couple of years back. So yeah, so right now you can see that I'm extracting my hand gestures statically at this point, and at the same time I am overlaying an emoji corresponding to that gestures, corresponding to that gesture. Okay. Uh, so yeah, so right now, if I'm pointing the thumbs up, giving a thumbs up to the webcam, it's doing the same thing. Now this is emoji for a dog, and then similarly you will have other emojis as well. So I'm making predictions at runtime. The important thing to notice here is that it's pretty fast, so you don't have to worry about a lot of resource crunching because you're working with a lot of filtering in the backend. You're only working with black and white images, so it makes a lot of sense. Okay. At the same time, you can definitely have a look at the entire code. It's on my GitHub, but let's just move ahead. So this is a V2 version, which we will not discuss at this point, but it has something to do with a much more advanced algorithm for object detection. So right now, instead of having some filters in place, I have an object detection API which detects my hand gestures from the entire image. Like uh, using my color image. So even if I had some background noise, this will still work, but it is very heavy on resources. Okay, then similarly, if you have done this, you can do something fun with the application. So this is what I did based on the gestures that we were seeing. I developed a simple rock, paper, scissors application or a game that you might have actually played as a kid. So yeah, so this is me playing rock, paper, scissors with the CPU, and you can of course get the result in real time. So this is pretty fast. It's getting my hand gestures, it trying to see whatever I'm corresponding to, and then based on that, CPU picks up one of the emojis randomly, and then whether it's a draw or a win or a loss, it tells me at runtime. This is just for fun. So till now we have seen, how we are drawing using our hand gestures, or whether you're drawing using your fingers. Now let's look at some eye aspect ratios. So one of the important aspects of machine learning is actually using a pre-trained model for your own advantage. Okay, because you cannot expect yourself to try and train everything from scratch, because after some point, because it takes resources. You don't want to waste resources. If somebody has already done that, you can just pick up their implementation. Of course, you can add them in the references, but pick up their implementation, try to better them at some point, and just give it back to the community. So we'll be looking at some of the I I as an I as something that you could feed to our system. So essentially, this will look at the different features of eye, basically when the eye is closing, when it's opening, and then depending on that, we have different applications. So we have something called as DLib, which is a library in computer vision. It is a pre-trained model for detecting different facial features. Okay, so if you see, we have face utils and getting the landmarks of my left eye and the right eye, which is a pre-trained model. We have a eye aspect ratio function, which we will not discuss in detail, but just try to understand that it gives me the ratio, or it tells me whether my eye is closed or not. Okay, just keep it. Let's keep it simple. So what we do is, of course, we do cap.read, which means that I'm going to read from my from the webcam. Okay, and I'm trying to detect some faces. I just want to detect some faces. Okay, and then within the face, what I'm going to do is I'm going to get the left eye and the right eye, and then once I have that information, or once I have those coordinates, I calculate the eye aspect ratio. Okay, and once I have that, I draw contours. So right now we are finding contours. Now we can even draw some contours. Okay, let's look at how we are drawing contours. Okay, so and if the eye aspect ratio is less than a threshold value, and if it is less than a threshold value for some amount of time, we can simply display an alert stating that the person is sleeping or he is drowsy. Okay, let's look at that in example. Okay, so yeah, so right now you can see that my eyes has some green outline, and that is done using draw contours functionality. So we were finding contours, now we can even draw some contours. And if I'm closing my eyes, my eye aspect ratio drops to a certain value, which is a threshold value. And you can see that after a certain amount of time, there is a alert that is being generated. You can use similar technique to have a Morse code decoder as well. So somebody, people who are less fortunate than us, who cannot speak or do not have any motor functionalities, can use Morse code to communicate. So right now Morse code is in dots and dashes. So a small eye blink means a dot, a longer eye blink means that I'm dashing, and then you have these dots and dashes corresponding to different alphabets. So similarly, I'm trying to print hello, and you can see that the Morse code for the hello is on the screen as well. So I'm trying to make sure that I write it correctly, so that it's, of course, it's a bit hard process, but at the same time it works for people who are less fortunate than us. So yeah, it's open for interpretation. You can of course have a look at that, even improve it if you want to. So yeah, now we'll come to facial recognition. So we have discussed hand gestures, fingers, feeding through webcam. We also looked at some eye features. Now we look at some facial features or facial recognition in general. Okay, so we have a technique or a research paper called as face nets, which is beyond the scope of this presentation at this point, but it's good to have a good knowledge of it. So let's so before we start, we have a function for getting the encodings, which is basically you feed your face to the image or to the function. It gives you a very unique number. Okay, and that number is not an integer, it's a float number, which is different, which is very different for different people. Okay, so let's say if my face has a number of 1.2 or 1.33334, Abhishek will have somewhere between 2.7, which means that we both of the faces are different. So this image to encoding function does that for us. Okay, and how it does that is beyond the scope at this point. But if you want to have a look at that, or if you want to understand, read the research paper called as FaceNets, which is one of the initial research papers for facial recognition. Of course, if you want to have a discussion with me, feel free to do that as well. But for the sake of argument, let's just assume that it gives you a very unique encoding. Okay, and then you can add all the photos of the valid people in the database. So that's what I'm going to do. Okay, and this is an important functionality. So once I have the image, I try to get the difference between the encoding from the face and the encoding that is present in databases. So we can have, let's say, 10 faces, so it's going to compare compare the distance between the face on the webcam to all the faces that are in the database, just to make sure that I get if a person is present in my database, so that I can say that this is actually an authenticated person, so he can access this. Okay, so if it is less than some distance, so if distance that we calculated is less than some minimum distance, it's going to get display the identity. So let's look at that in action. So right now in this video that you will see, it has my brother and myself. So his name is Apur. So you can see that I have two faces in my database. One is Apur, one is Akshay. So right now I'm feeding myself my face, and the distance is 0.0009, which means that this webcam, this image from webcam is very close to an image from the database, which corresponds to Akshay. Okay. And one additional feature that I added is that if I'm not looking at the camera, or if my eyes are closed, then there will not be any predictions. Which means that, let's say if I'm not looking at the camera, then which is inspired from iPhone's functionality. That is, if you will have a face unlock only when you look at the camera. So now we have seen hand gestures, we have seen fingers, we have seen faces, we have seen eyes. So if we add all of these functionalities, or if I take out some functionalities, I can actually solve a problem. So what I solved is called as Indian Sign Language Recognition, or ISL, ISLAR, or ISLAR, which means that I want to develop and standardize an Indian Sign Language Recognition system. Okay. So what I did was I did not take the entire image into account, because I knew that I could filter out only the relevant information. That's what I did. So this is how my dataset looks like. So right now you can see that I have only extracted out my facial features and my hand gestures. Okay, so this is pretty interesting because you are not worried about about the entire image. You are only worried about the image that you are interested in, or the part of the image that you are interested in. Similarly, these are not all the gestures, but some of the gestures that I developed. And if you want to have a look at that in action, this is how it looks like. So right now you can see that I have a lot of background noise in my image, but still I'm only working on this part of the image, which means that I don't have to worry about a lot of background noise. I can still make predictions at runtime because I filtered out all these informations. Okay, so you can have a look at this implementation. It's not on my GitHub currently, but it is on my I have written a blog on that. So definitely feel free to reach out to me if you want to get more details on this. So right now we have seen a lot of things. We have seen hand gestures, fingers, facial features, eyes, other facial key points. Now we have something called as pose detection, which means that I want to detect the entire pose. And this is not one of my work that I've done, but the beauty about machine learning or the community is that people do a lot of things which they open source, and anybody or everybody could just go ahead and give that a try. So this is actually called as open pose by CMU, or Carnegie Mellon University. So some researchers at CMU, they came up with this algorithm and then they open sourced it. So let's have a look at that. So right now you can see that they're working with facial features as well as they're working with different poses. So you can see that you can work with just the skeleton based system from the entire image. So let's say if you have a lot of if you want to, let's say, work on the entire skeletal system of a human being, you can simply use this open pose library by CMU, and you can do that. You can do your work quite easily. I try to do something similar. So this is same thing that we just saw called as Emojinator. I try to do this using OpenCV, or sorry, not OpenCV. I try to do this using OpenPose. So right now you can see that it's not very clear at this point. Probably does not even make sense for me to integrate it with Emojinator at this point. But I just wanted to give it a try, and it performs really well. So if you're looking for something which has works with the entire human cellular system, you can definitely check out this particular implementation by CMU. Okay, so I think we have covered a lot of things. We have covered features, facial features, eye gestures, hand gestures, fingers, as well as now we have covered the entire skeletal system or human anatomy. So with that, I will like to say that I have concluded my my work. And if you have any questions, feel free to ask me. Right now, you can even go to my GitHub repository. You can ask questions there, or you can add me on LinkedIn as well. Feel free to give me any feedback if you have. If you feel that you want to, if you feel that I can improve it in some way, definitely feel free to do that. Go to akshayavadu.com. That's my website, and you can give me any feedback on my present work. At the same time, just want to thank you for everyone for attending the session. You can find the details again at this point, bit.ly/DEV Sangamam 20. You can find me at akshaybhadur.com, and at akshaybhadur3 is my Twitter ID. So feel free to ask me anything on Twitter as well. So that was it about myself and the presentation that I wanted to show you. If you have any questions, feel free to do that. I will be more than happy to answer any questions that you have. Okay, so I'm going to stop sharing now. Abhishek, I hope that's okay. Yeah.
Yeah, that's fine. Thank you so much for session. I guess we are open for questions. So you will be taking your questions. Then later on, Julie will be joining you. She got a lot of questions for you.
Oh, okay. Yeah, yeah, definitely. So do you want me to look at the live comments, or will it come directly on the screen? Yeah, so definitely, Google Colab does have the issue with real feed webcam, because when you're working with Google Colab, you're actually working on a VM. So let's say if you do something called as tab.read, or open the webcam, it's not going to open your local webcam. It's going to open the webcam of the VM where you're running the Colab notebook. So what I do is I train my models on the web on Google Colab, and once I've trained the model, that's when I download the model and I then run it locally. Okay, and if you don't want to do that, you can read about TensorFlow.js, which helps you do everything through the browser itself. Okay, so right now there's no alternative for running your local webcam on Colab. You cannot do that. So you just make sure that you download the model and then run it locally for using the local webcam. So dot flatten, what it does is that, let's say if I have a matrix of let's say 3 by 3 or x by x, and if I want to flatten it out to a single vector, not from a matrix to a vector, that's when you call a flatten function. So it's just going to roll the entire matrix into a single column or a vector. I hope that answers your question. uh, mm, so yeah, Bhavani, it is not mandatory. So everything that you saw, that everything that I developed was only using CPUs. Of course, using GPUs definitely help, but I did not have that liberty at that point, because at that time Collab was not very popular, and at the same time uh, I was unaware of Collab. So because, and hence you can see that all of these filtering that I did was just to make sure that I could fit the entire data set in memory, and I can perform computations in my simple laptop or in my local machine. I hope that answers your question. Yeah, so since mostly everyone is doing similar projects, yeah, definitely makes sense. When I started with machine learning, this was back in 2017. People were trying to get into the field of machine learning, and this they will definitely be the case at every point, because you have a lot of people that are interested in doing something. So the demand, so the demand is high, the supply is also high. So if you want to make yourself unique, working on something which is original is very important. So if you want to have a look at my example, I developed the sign language system, which was not done like the way that I have done by other implementations. By that I mean nobody was actually filtering out the or doing pre-processing on the image. They were just giving the entire image to the model to train. But I wanted to do something different. I wanted to make it more lightweight. Hence, I went ahead with that. So having some intuition of what exactly you want to achieve at the end will really help. So being original is one thing. At the same time, being consistent is also very important. So yeah, and then of course finding the right fit between a project that you work on, as well as if you have to deploy that in an actual system, how will you do that is also very important. So yeah, I hope that answers your question. Uh, so when it comes to machine learning, there are different aspects. Okay, so ML engineering comes from basically, so you have different tiers. So you have a research scientist, which means that, or a researcher, which will make sure that it creates these algorithms. You will have an applied scientist which uses these new algorithms and applies that to an to a problem statement and finds if it works or not. Then you have ML engineers, which will be responsible for actually pushing these models into production. By production, I mean that they have to be really thorough with the whole pipelining. Then you have data engineers, which closely work with machine learning engineers to make sure that your system is scalable. And then of course you have other layers. So if you want to develop algorithms that at the top, that is if you are a scientist, or if you're a researcher, then, and at the same time, if you're a researcher, it gives you a lot of you should be very thorough with your mathematics. You should be thorough with your statistics. But once you start coming down, let's say if you go to machine learning engineer, you have to be thorough with your computer science slightly more than your mathematics. Of course, having knowledge is very important, but if you go down this hierarchy, your computer science skills will start increasing and your mathematical skills will start decreasing. I hope that answers your question. How do you explore these projects? Any tips? First of all, I think it's very important to understand why exactly are you exploring any project. So by exploring any project, it means that you should have a end goal, or maybe a slight intuition of what you want to do. So let's say if I keep on jumping from doing one project to another, I will probably be good at that particular project, but I cannot apply that to solve a problem. Okay, so let's say if you're working with NLP, then if you switch to computer vision, then you switch back to NLP, then you switch to maybe RNNs, or so you keep switching. That means that you have knowledge of everything, but you have not specialized in something. Okay, so what I will suggest is that make sure that you have a bigger picture in mind, that this is what you want to do, and then keep exploring, because every field or every specific every specific subdomain of machine learning is very unique and very vast. So just make sure that you know what exactly you want to do. I hope that answers your question, Abhishek. How does one understand where to apply? Yeah, so this is actually a very interesting question. I haven't heard this question before. I keep on asking this question. But according to me, a good machine learning engineer knows where to apply machine learning, algorithms, but a great one knows where not to apply these machine learning algorithms. So let's say, to give an example, let's say if I have to have a machine learning algorithm where I want to predict the number of leaves that are falling from the tree. So let's say I have a lot of trees and I want to predict that within a given month, there will be, let's say, 1,000 leaves that fall. So I want to make a prediction algorithm. Let's say, because during the month of fall, or what you call in Hindi as patjhad, you will have a lot of falling trees. So I want to predict that. So we'll go ahead, you will collect the data. Basically, you will count the number of leaves that have fallen over an year, and then you will have enough data to make your model. But the important question to ask here is that, is it really necessary for a model to do all this? Maybe the problem is much simpler than that. Maybe it's not even required, or maybe the problem is not even a problem because we don't really care about if the leaves fall or not, because this is just a cycle that keeps on happening. So if you predict the number of leaves that have fallen from the tree, it is not going to help anyone. So I hope that answers your question. So the short answer is to just keep on practicing. Once you have that practice in place, things will become much easier. Where do you see ML development in the next 5 years being necessary in various? So there are definitely, I feel that every field has a lot of scope, but coming from India, if I have to talk about Indian system, which I've already covered in my last topic for GDG Chennai, is that I definitely feel that if we do good work in the field of agriculture and healthcare using machine learning, it's going to be really helpful because it is going to affect a lot of people. It's going to make people lives a lot better, and at the same time, it's going to affect a large number of people. So because agriculture, India, around 80% of Indians are directly or indirectly attached to agriculture. So if you make something revolutionary using machine learning in agriculture, 80% of Indians will be affected by you. So I think that these two fields are very important personally to me. What is your advice? I think the best advice is to keep being consistent. If you really like machine learning, just you have to make sure that you have the basics correct. At the same time, you should also have the basics of computer science, which I just saw in the last lecture. That basics of data structures, algorithms are very important because at the end of the day, all these algorithms runs on a computer, and you want to make sure that your computer is optimized enough to run these algorithms. So you have to understand these basics at any given time. Okay. All right. So I think these are all the questions. Yeah. So if of course, if you have any other questions, feel free to reach out to me. You can find me on my website on LinkedIn. Okay. Hi,
Okay.
Julie.
So thank you so much for this amazing and informative session. And being an ML enthusiastic, I really enjoyed it. So,
Thank you
like
so much.
Abhishek mentioned, I have few questions. So by
Sure.
now you must be knowing our tradition, or even if you don't know, it's okay. Let me tell you. So I'll now ask you 5 questions, and this is gonna be like
Okay.
a rapid fire round. Are
Rapid
you
fire.
ready?
All right. Yep. I
Okay.
hope so.
What does research thinking is different from startup thinking?
Uh, Actually, don't know because startup thing is mostly about getting the product ready and shipping it out to customers. Research and thinking is basically you want to make sure that you develop something new, which can affect a lot of people. So I think that's the main difference.
Okay, thank you so much. And the next question is describe your GDE experience in 3 words.
It has been enlightening. It has been fun, and it has been really informative.
Wow, that sounds really interesting. Okay. So, like we all know, you have worked on so many ML projects, and definitely you might have seen some other ML projects as well. So, what is
Yeah.
your favorite ML project that you have seen recently?
So recently, I actually explored this project by Young, which is a TensorFlow JS, which is called as pose animator. So basically, it you have it, and it works on a webcam. So you don't have to actually install anything. It works on a webcam. It's using TensorFlow.js. So you just go to that website, and it has an avatar of you. So whatever you do using all the poses that you do, maybe your facial expressions is going to copy that. It's going to copy your hand gestures, your every moment. So I found it pretty interesting.
Okay.
Yeah.
And the next question is how do you see data of users in terms of privacy when a product is using user data for ML?
Uh, I think that is definitely a concern because right now data is becoming something that is very important for every company and of course for users as well. So right now, if you look at so what I do is basically if I am if I'm installing an application, I try to read the data policy that how exactly will they be using my data. At the same time, if algorithm runs on your system itself, so let's say uh, what Apple does is that all the machine learning is done on on your mobile phone itself. So that means that the data is secured in your mobile phone. So make sure that if you are scared about something like this, feel free to make sure that you read all this information from the developers itself.
Thank you so much. And the last but not the least, have you ever been to Chennai?
Yes, I have actually. So I have been to Chennai. I stayed there for a week. I stayed in actually T Nagar, and this was way back in when I was a kid, and but I remember it very clearly. And I actually went to this great idli place called as Murugan Idli Shop,
Yeah.
which is very popular. And that was my first time, and I had a lot of fun because I thought that the food was really great. So yeah, so definitely I would like to visit Chennai again. Yeah.
So, which is your favorite place?
Uh, Visited in
Chennai.
Chennai.
Yeah.
So basically, when we came, we just went for shopping. So my mom is very is sari enthusiast. So she went to Nalli.
Okay.
I actually liked the place because it was a pretty huge building for a sari shop. Then I went to a couple of malls. We had, I think, Sarvana Mall, if you remember. This
Yeah,
was way
sir.
back.
Yeah.
Yeah, so I went there as well. But definitely, the best place is of course the Murugan Idli shop because I had a lot of cheap
Amazing.
idlis. Yeah,
Nice. So thank you so much, Akshay, and it was pleasure introducing you and having you on
thank
board.
you so much. Yeah,
So thank you so much.
all right. Thank you
Now
so much.
over to
Thank you.
you. Okay, yeah. Bye bye. Over
Yeah.
to you, Abhishek.